Hi everyone, my name is Peter. Today I will be explaining to you the definition of the natural logarithm. Now to begin, they usually define the natural logarithm ln as e to the power of x. And usually the natural log is used to calculate and determine certain decline or a growth of something, say population, something like that. Um, e lets us take a simple growth rate, and helps us find the impact of uh, a continuous growth rate, and basically after the calculations, it helps us determine the the rate it's growing, and in the natural logarithm, every bit of second it grows, it only grows probably almost every second it grows. It grows very, uh, it doesn't grow that much, but not every second. But probably after time, it exponentially grows. Um, Now ln gives us the time needed to reach a certain level of growth. Now ln to ln x, at any constant, ln x lets us plug in the growth, and it helps us calculate the time it would take for it to grow. For an example, we have uh, say we have e to the 3, e to the 3. Say I have e to the 3, which equals 20.08. Now after basically the 3 that's raised is say let's give it a couple of units of time, and then we end up with 20.08 times with what we began with. Now if we take the calculation of 20.08 and put it to n, the ln of 20.08 basically means it's about 3, which is, if we wanted the growth of 20.08, we wait 3 units of time, assuming that the growth rate is at 100% and it's continuous. So that's very important also. Continuous rate also determines how much it grows or how much it declines. Now for the properties of the natural logarithm, there are various properties. It's comparable as to addition to multiplication, subtraction to division, negation. If the log is negated, then it converts as a reciprocal, as well as multiplication, which ends up being the exponentiation. I'll show you right now. It's actually right here. Now, as you can see, we have addition to multiplication. Basically, if we put it all together, if we add a log to a constant, log to the base, a constant base to the x plus a log to the constant base to the y, we get a log to the base x times y. As you can probably see for the rest, almost probably for the rest of them. There you go. Now we have subtraction to division. Now if we actually have log to the base c to the times the x, and we subtract it to the log base c to that should be, I can't even do this, it's on a camera, it's so hard. That should be a y. Then it's log c, it's calculated as log to the base c x divided by y. From negation to reciprocal, now we can never have a negative number right there, because the natural log is always growing, but it does end up right over here. So the negative log base of the c to the y equals log base c 1 over y. And if we multiply something to the log base to the x, then we end up with log c y to the power of x. And 0 is always log ac to the 1. Now to explain that, we have, here's a graph of why it happens. The graph of ln x. The graph of ln x should look like this. Now as you can see, as it goes down, as it's going down, it's an infinite yeah, it never touches 0, and it's always going down, as the rest of the graph is always going and moving up at the same time. So that means it's exponentially increasing most of the times. So, the natural log. Alright, well hopefully that did something. Hopefully that explained something about the natural logarithm. If you want to know more, there are various resources online, or you can also come to me for it, or not if you don't want to. But that is the natural log.